Welcome to A Square Maths by I. Here we are going to study today Laplace Transform Part 1. In the Part 1 we are going to study basic definition of the Laplace Transform along with Laplace Transform of standard functions. First, definition of Laplace Transform. Let us define a function f of t for all positive values of t, then Laplace transform of f of t, which is denoted by L in curly bracket f of t, or f bar of s, is defined as f bar of s is equals to Laplace transform of f of t, that L in curly bracket f of t is equals to integration from 0 to infinity e raised to minus st f of t dt, provided that the integral exists and s is a parameter which may be real or complex. यहाँ यदि देखा जाए तो लैप्लास ट्रांसफॉर्म ऑफ एफ ऑफ टी ए इन टर्म्स ऑफ एस में ट्रांसफॉर्म होता है फंक्शन बाय यूजिंग द इंटीग्रल 0 to infinity e raised to minus st f of t dt, as the integral is free from s, that means whatever the integration we take with respect to t, and s is the part of the integrand, so s is called as the parameter. And whatever the Laplace transform of f of t, we do have the t domain function, we transform it into the s domain function. Next, let us see the linearity property of Laplace transform. If f of t, g of t, h of t be a function of t and a, b, c are constants, then Laplace transform of a f of t plus b g of t plus c h of t is equals to a Laplace transform of f of t plus b Laplace transform of g of t plus c Laplace transform of h of t. Proof of the statement is, we have by definition of Laplace transform of f of t is equals to integration from 0 to infinity e raised to minus st f of t. Here f of t will be replaced by whatever the addition of three functions a f of t plus b g of t plus c h of t, and we will apply the definition of Laplace transform, integration from 0 to infinity e raised to minus st, and this function as it is. And hence you know very well integration is the linear, so by the linear property of integration this constant a will come outside. Integration from 0 to infinity e raised to minus st f of t dt plus b integration from 0 to infinity e raised to minus st g of t dt plus c integration from 0 to infinity e raised to minus st h of t dt. And by definition of Laplace transform, this is nothing but the Laplace transform of f of t, this is nothing but the Laplace transform of g of t, this is nothing but the Laplace transform of h of t. So by definition of Laplace transform we can say that, or we can prove that this one is nothing but the Laplace transform of f of t, this is nothing but the Laplace transform of g of t, or a Laplace transform of h of t, hence the proof. Now हम ऐसे कुछ प्रॉब्लम्स लेंगे जिसमें Laplace ट्रांसफॉर्म निकालने के लिए फंक्शन कुछ इंटरवल के लिए स्प्लिट हुआ है. सो here we have taken find Laplace transform of f of t is equals to cos of t for t lies between 0 to pi, and f of t is equals to sin of t lies for all t greater than pi, that is pi to infinity. Now whatever the integral of e raised to minus st f of t dt it will be splitted from 0 to pi, and f of t will take value cos of t, and from pi to infinity f of t will take value sin of t, because we do have the function like this. Hence integration from 0 to pi e raised to minus st cos of t dt plus pi to infinity e raised to minus st sin of t dt. Now we are going to find this value of this integral and this integral. Now we have integration from e raised to ax cos of bx is equals to 1 upon a square plus b square e raised to ax a cos of bx plus b sin of bx, and e raised to ax sin of bx dx is equals to 1 upon a square plus b square e raised to ax a sin of bx minus b cos of bx. By using this integral formulas, first integral formula will be applied here and second will be applied here. Here a is minus s and here is b is 1. Similarly here. So 1 upon a square, that is s square, b square is 1, e raised to minus st, a is here is minus s cos of t plus sin of t, limit will be from 0 to pi, plus second integral is similarly 1 upon s square plus 1 e raised to minus st minus s sin of t minus cos of t, and limits will be from 0 to infinity as in integral. Now this 1 upon s square plus 1 is common in both, so we will take outside. Putting the limit, this is minus, this one will be the pi. If you put pi here, e raised to minus s pi, and this will be a minus s cos of pi plus sin of pi, but sin of pi is 0, so it will be only minus s e raised to minus pi s, but cos of pi is minus 1, so this minus and minus 1 will get cancelled. I have taken here direct s e raised to minus s pi. By putting lower limit 0, e raised to 0 is 1, cos of 0 is 1, and e minus s and lower limit is minus, so minus minus, in next step it has become plus for this one, and sin of 0 is 0. For this term, e raised to minus infinity upon and into here is infinity. If you put limit t tends to infinity, it will be a 0 by the L'Hospital rule, and for lower limit, if you take minus sin of pi is 0 and cos of pi is 1, minus 1, so minus minus plus 1, but lower limit is minus, so it will be a minus. And by simplification, e raised to minus s pi, e raised to minus s pi, that is s minus 1 e raised to minus s pi, and this minus minus will get plus, that is s. It's a required Laplace transform of the function. Let us take another sum. Find Laplace transform of f of t is equals to t when t varies from 0 to 4 and f of t is equals to 5 for t is greater than 4. Again, similarly, by definition of Laplace transform of f of t is equals to 0 to infinity e raised to minus st f of t dt. This one is the proof. The integral will be splitted in two integrals because the function have been defined into interval from 0 to 4 it is t, and for t greater than 4 up to infinity is 5. So by replacing f of t by t, but for t f of t varies from 0 to 4, and this one is for 4 to infinity 5 dt e raised to minus st as it is. Here by using Integration by parts, t as it is, integration of e raised to minus st is e raised to minus st upon minus s, minus derivative of t is 1 and integration of this term is e raised to minus st upon s square. 0 to 4, it is minus s and again minus s, that is minus s into minus s is s square. 5 will be outside and integration of e raised to minus st is e raised to minus st upon minus s. By putting limits, if you put 0, this term will become 0. If you put 4, this one will be the low. This minus sign I took outside, minus 4 by s e raised to 4s. Then here e raised to minus 4s upon s square. Then by putting lower limit, this one will be the 0 and this one will be the minus, but lower limit is again minus, this will be a plus. E raised to 0 upon s square, e raised to 0 is 1 upon s square, plus upper limit is 1 upon infinity, it will be a 0 and lower limit is minus 5 by minus s, that is plus 5 by s e raised to minus 4s. And if you simplify, 1 upon s square is common, minus 4 by s plus 4 by 5 by s, it is 1 by s, and minus 1 upon s square will be as it is, e raised to minus 4s will be common. So it is the required Laplace transform of this function, where point of discontinuity is 4. Some standard Laplace transforms. Laplace transform of 1. Here is by definition of Laplace transform. Laplace transform of f of t is equals to 0 to infinity raised to minus st f of t dt. F of t replaced by 1. E raised to minus st upon minus s, 0 to infinity. If you put upper limit, e raised to minus infinity minus e raised to 0 upon s. So e raised to minus infinity is 0 and e raised to 0 is 1, and upon minus 1, that is 1 upon s. Laplace transform of k. K is constant. By definition of Laplace transform, as usual, integration from 0 to infinity e raised to minus st f of t dt. F of t will be replaced by k, and in k is a constant, so it will be outside, and integration of e raised to minus st is e raised to minus st upon minus s. By putting limit, this will be a minus s and k upon s. Laplace transform of cos of at is, by definition of Laplace transform, integration from 0 to infinity e raised to minus st f of t. Since we have f of t is equals to cos of at, Laplace transform of cos of at is equals to integration from 0 to infinity e raised to minus st cos of at dt. As we know, integration from e raised to ax cos of bx dx is equals to 1 upon a square plus b square e raised to ax, a cos of bx plus b sin of bx. So this one will be the 1 upon s square plus a square e raised to minus st minus s cos of at plus a sin of at. Integration limit will be from 0 to infinity. For lower limit, for upper limit, this one will be a 0, and for lower limit, e raised to 0 is 1, 1 upon s square plus a square as it is, cos of 0 is 1 and sin of 0 is 0. So by simplifying, we will get it Laplace transform cos of at is equals to s upon s square plus a square. Similarly, you can find the Laplace transform of sin of at is equals to a upon s square plus a square. Let us take f of t is equals to sine of at. Laplace transform f of t is equals to 0 to infinity e raised to minus st sine of at dt by using the formula of integration e raised to ax sine of bx dx. We have this quantity. By putting upper limit and lower limit, you got this one and a. Similarly, you can prove the formulas. So list of the formulas I am giving directly. Laplace transform of 1 is equals to 1 by s. Laplace transform of k is equals to k by s, where k is constant. Laplace transform of t raised to n is equals to gamma n plus 1 s raised to n plus 1. Laplace transform of e raised to at is equals to 1 upon s minus a, for s is greater than a. Laplace transform of sine of at is equals to s square plus a square, provided that s is greater than 0. And Laplace transform of cos of at is equals to s upon s square plus a square. Laplace transform of hyperbolic sine of at a upon s square minus a square, for s is greater than mod of a. And hyperbolic cos of at is equals to s upon s square minus a square, for s greater than mod of a. Examples: Laplace transform of a is a constant, a upon s. Laplace transform of t raised to 5, as we know, Laplace transform is t raised to n is gamma n plus 1 upon s raised to n plus 1. Here t raised to 5, Laplace transform of t raised to 5 is gamma 5 plus 1 upon s raised to 5 plus 1, that is 5 factorial upon s raised to 5 is equals to 5 factorial is 120 divided by s raised to 6. Laplace transform of e raised to 4t is 1 upon s minus 4, since Laplace transform of e raised to at is s minus a. Laplace transform of sine of 3t is equals to 3 upon s square plus 3 square, that is equals to 3 upon s square plus 9, since Laplace transform of sine of at is equals to a upon s square plus a square. Laplace transform of cos of 70 is equals to s upon s square plus 7 square is equals to s upon s square plus 49, since Laplace transform of cos of 80 is equals to s upon s square plus a square. Laplace transform of sine hyperbolic 90, or you can say sine 90, is 9 upon s square minus 9 square, since Laplace transform of hyperbolic sine 80 is a upon s square minus a square. Hyperbolic cos of 3t is equals to s upon s square minus 3 square, that is equals to s upon s square minus 9. Hyperbolic cos of 80 is equals to s upon s square minus a square. If you like, share and subscribe.